to session 1 of the chapter, frames of reference. Before we go with frames of reference, let us understand how to describe the position of an object in physics now here, right? Okay, I want to describe the position of an object. For example, let me take like this. If you are standing at this position and you get a call from your friend to know where are you, and you tell him that you are standing at this position, means you don't say that okay, I'm standing at this position, this latitude, this longitude. You are not saying to him, you give a point of reference which he knows, and you are saying that okay, beside of that I'm standing. For example, if there is a petrol bunk here, okay, let me consider there is a petrol bunk, okay, here there is a petrol bunk, and you tell to him that okay, you are standing at the left side of the petrol bunk. Right. So there might be another one case that he doesn't know where actually the petrol bunk is. Again, you will be changing the point of reference, and you say that okay, you will think of a position which everybody knows. Right. You just check it out and find that there is a bus stand here. Right, and you say that okay, come to the bus stand and I will be telling you where I am now here. Right. So you are changing the point of reference now here, right? Okay, so let me imagine this case and let me explain how to describe the position of an object now here, right? Okay, now this is a petrol bunk and this is the bus stand now here, right? When you describe the position of an object with reference to the point of reference, right? So that is called as the position of an object. So what is position of an object? Position of an object is the location of the object with reference to the point of reference, right? Okay, this can be expressed by using certain coordinates now here, right? For example, why we need the coordinates to express the position? You can say that okay, I am standing the left side of the petrol bunk, but there might be one problem, right? Okay, let me tell that. If this is a duster, I say that the duster is moving left side. You feel that the duster is moving right side. Okay, that is the problem. Right, so we cannot say right side or left side of an object. We need to explain the location of an object with certain coordinates. That is the reason why we introduce coordinates in physics now here, right? We will be taking certain coordinates and we will be explaining, okay, this is the point where the object is, right? I am considered this is as an object. Okay, let me replace this by this point now here. Let me take, I want to express the position P now here, right? Position of the point P, right? Instead of taking petrol bunk, I will be taking a coordinates like this. Let me take, this is a X coordinate, and let me take, this is a Y coordinate now here, right? Why I need these coordinates? That is the reason I told you that you cannot say left side, because it will be confusing now here, right? So to express it completely, we use the coordinate systems, right? So x-axis, y-axis. If this point is outside the board, I can use another one axis called z-axis. So these are the coordinates I will be using, right? If it is 3-dimensional, if the object is here at this point, I need x-axis, y-axis as well as the z-axis, right? So this is x-axis and this is y-axis. Z-axis is perpendicular to the plane now here, right? Okay, since the point is on the board itself, for simplification's sake, I can take only the two axes, x and y. Okay, I need to explain where actually the object is. Okay, this point of reference I'll be considering as the origin here, right? Okay, for example, if I'm taking what is the distance here, right? If I'm considering this is 1, 2, 3, 4, first you will be explaining in terms of x and y. So these are called as Cartesian coordinates, because coordinates are many. You can use polar coordinates, you can use cylindrical coordinates, you can use Cartesian coordinates. Okay, we'll be seeing those coordinates later, but the simple coordinates that can be used is Cartesian coordinates. First let me introduce Cartesian, later on I will be going with the polar coordinates now, right? So what is Cartesian coordinates, right? So this is xy is the Cartesian coordinate. What is the distance of this position from along the x-axis now here, right? Along x-axis, what is this position? If I find what is this position, position is 4, right? What is the position of point P along y-axis? Okay, this is along y-axis. If I am considering this along y-axis, 1, 2, 3 and this is 4. So this is along y-axis. Let me consider it as 4, 4, right? So this 4, 4 is the position of an object with reference to the point of reference with respect to the origin. So these are called as coordinates, and this is how we express the position of an object. Right, but if you change the point of reference, what happens? Okay, instead of taking a petrol bunk, I will be taking a bus stand. What happens? Again, you can create the coordinates like this, right? You can create again x-axis and y-axis. Instead of this, let me take, I will be creating unknown axis. Let me take it as x dash. Let me take unknown coordinates. What is that now here? Y dash. Now this point of reference, let me take it as O dash. Right, now I will be explaining the position of an object with respect to this coordinate system now here, right? Okay, what is the distance? Let us check it out now here, right? For example, it is 1, 2, and if I am considering it is 3, and this is 4, this is 5, this is 6, 7, 8, and if I am considering like this, right? So 1, 2, 3, 4, 5, 6, 7. Right, so if I'm taking 1, 2, 3, 4, 5, 6, 7. Now I need to explain this position with respect to this axis, not this axis now here, right? I am changing the coordinate system now here, right? For example, if I am writing with respect to this coordinate x and y axis with respect to the bus stand which I am taking here, right? So what is that? Okay, this can be expressed, this position can also be expressed with respect to x dash and y dash. If I change the point of reference now here, now what is the position of the object with respect to this frame now here, right? Okay, I'll be introducing a word called frame, right? That is the main thing. I need to introduce about the frame of reference. So I'm changing the frame now here, right? I'm changing the petrol bunk to the bus stand. Okay, now come on, tell me what is the position of an object? Position of the object is, if I am considering this, if I am including, it is about 7.5. Okay, for example, if I am taking, it is about 7.5. If I am considering 2 here, along y-axis, it is about 7. Means what is the position along the x-axis if I consider this frame here, right? So if I am calling this frame and this frame, let me call it as S, and this frame, let me call it as S dash. So S is a frame which is related to the petrol bunk, right? Considering the petrol bunk, if I consider the bus stand, I will be changing the frame. So I will be changing the frame to S dash, and here X dash and Y dash. So this is how the position can be expressed in terms of Cartesian coordinates, right? So what is the position of an object? Position of an object. Okay, what is position of an object? Position of an object. See, the position of an object is its location. Do you understand? The position of an object is its location with respect to a reference point. With respect to a reference point. Position of an object is its location. Do you understand? It is its location with respect to the reference point. So reference point, it might be anything now here, right? It might be petrol bunk or it might be bus stands now here, right? Okay. So position of an object is its location with respect to reference points. Okay. Now, in order to describe how the object is, okay, there might be two things. The object may be at rest, the object may be in motion. How to describe that? Okay, how to express mathematically again, right? A body is said to be in motion. A body is said to be in motion if it changes its position with respect to time and its surroundings. Okay, let me take like this. Okay, when the body is said to be in motion, a body is said to be in motion if it changes its position, right? If it changes its position, that too with respect to time. Okay, there is another one physical quantity which we are introducing here is about the time now here, right? Okay, so a body is said to be in motion if it changes its position with respect to time and it's what we say now here, surroundings. For example, if you are moving from the position P, right? If you are standing here and until your friend reaches to the point of reference, you moved at this point now here, right? If you are changing like this and you are moving at this place, for example, this is 8 now here, right? So if you move along the x-axis, so let me call it as P and let me call it as P dash now here, right? For example, you have changed the position now here, right? If you change the position, what happens to the coordinates now here? Now, along x-axis, how much is the distance now here? Along x-axis, it is 8. Along x-axis, it is 4. Earlier, it was 4, 4. Now it is 8, 4. Right, means a body is said to be in motion if it changes its position. Okay, the position is changed with respect to time. Earlier the time was 0, now the time is, let me take after time t now here, right? After time t, the position has been changed. If the position of an object changes with respect to time, then the body is said to be in motion. Do remember this, right? So these are called as coordinate axes now, right? Coordinates. So there are axes x and y. For simplicity's sake, I took only the two axes, right? If the object is in space, if it is moving in space, I can consider this axis also, and that is z axis. Right, okay, a body is said to be in motion if it changes its position with respect to time and its surroundings. Right, okay. Now, let me tell you, when the body is said to be at rest, a body is said to be at rest. Do you understand? When the body is said to be at rest, right? So, the body is said to be at rest if it does not change. If it does not change its position with respect to time and its surroundings and its what we say here surroundings. Simple, right? When the body is said to be at rest, a body is said to be at rest if it does not change, right? Change its position with respect to time and its surroundings. If position is not changed, then the body is said to be at rest. Okay, we have understood when the body is said to be in motion and when the body is said to be at rest. But there is one problem here. Okay, let us check it out. What is that problem? A body, let me tell you that concept first now here. A body at rest with respect to one observer may be in motion with respect to another observer. Another observer. Okay, see here. The question arises here is, can we tell the body is at rest or motion simply by understanding the change in position with respect to time? No, right? So, a body at rest with respect to one observer may be in motion with respect to another observer, right? For example, if you are sitting in a bus here, okay, let us consider there is a bus here, and if you are sitting on the seat here, right? If I am sitting on the seat and your friend is also sitting here, right? And the bus is moving here, right? Right? And if you see as a bus as the frame, bus as the coordinates, right? Okay, if I am seeing bus here and the position of this person is not changing with respect to bus. Okay, if he is sitting on the seat itself, he is sitting on the seat. The position is not changed with respect to what we say here, bus. If I am considering this is x-axis and if I am considering this is y-axis, the position is not changed. This person feels that this person is at rest. Right. For example, if this is A and if I am considering this is B, A person feels that B is at rest. Right. But if there is a ground here and if there is another one person who is standing, let me call him as C. Right. So he takes this ground as the reference here, right? So this is a frame which he is considering, right? So let me take, this is what we say here, x frame here. Now the bus is moving with some velocity, the bus is moving with the speed. Now this person feels that this B is moving from this point to this point when the bus moves now here. Means the position of B is changed with respect to observer C, and C says that B is in motion. A says that B is in rest. Okay, did you understand? Now we have two frames here, right? A is seeing inside the bus, right? He is sitting inside the bus and seeing B, and he says that okay, the position of the B is not changing with respect to time. B is at rest with respect to observer A, but B is in motion with respect to observer C. Means the object is same, but one is feeling that he is at rest, another one is feeling he is in motion. That is why we say motion is a relative concept. Okay, let me tell you that a body at rest with respect to one observer may be in motion with respect to another observer. Thus, okay, let me tell you that the motion is what we say here, relative. We cannot say the object is at rest or in motion, right? So absolutely we cannot say that, right? But with respect to one frame, we can say the object is at rest or it is in motion here, right? Okay. Next question arises here is that let me take another one example here, right? For example, if I am saying that, okay, if I'm saying if a person is sitting in front of me, if he is sitting on the chair here, I can feel that okay, the body, he is at rest here, right? But if I jump out of the earth, for example, if I'm sitting here and my friend is also standing here, if he is sitting on the chair here, right? For example, if I'm considering he is at this position, I can feel that the observer is, I can feel that the friend is at rest here, right? He is standing in front of me. I can feel that okay, he is at rest. But if I jump out of the earth, and if I see that person, I feel that the person is in moving because earth is moving, right? Okay, since earth is moving, the person is also moving if I see him, if I go out of the earth and if I see him, right? So means we need to know which frame we are speaking, right? That is why there is a need of the frame of reference to describe the object is at rest or in motion. First of all, we should know from which frame we are seeing that motion here, right? If you understand with which frame we are considering, so that frame we call it as the frame of reference. For example, the frame of reference requires the coordinates as well as time, because at which time where is the object. If I am considering the coordinates as well as time, if I combine both, I will be getting what is the frame of reference. Now let us understand what actually the frame of reference is now here. Now let us move on to the meaning of frame of reference. A frame of reference is a frame. It is a frame with respect to which a position or motion of an object can be described. Okay, see here. It is a frame with respect to which a position or motion of an object can be described is called frame of reference. It is called as frame of reference. Okay, simple. What is frame of reference? It is a frame with respect to which the position or motion of an object can be described. We have already learned that motion is relative, right? In one frame we find the object is at rest, in another frame we find that object is in motion. That is why we need a frame of reference. So frame of reference is a frame with respect to which the position or the motion of an object can be described. Right, the frame may be ground, the frame may be bus, the frame may be car, anywhere, right? From where you are observing the object, that itself is a frame here, right? A frame with respect to which the position or a motion of an object can be described is called frame of reference. In the earlier example which I took, there was a bus and you are seeing and you are standing here and your friend is sitting here, right? This is A we called and we called it as B. We found that B is at rest with respect to A, means A is seeing B in the frame of a bus. That is why the bus becomes frame of reference. And there was another person who is standing here, right? We took this example, and this person we called it as C. C is seeing B with respect to ground, and this ground becomes frame of reference to C. Means we are seeing here two frames. One is the bus as a frame, and another one is ground as a frame. Means we can describe the body's rest or motion by considering the frame of reference. That is what we describe here. It is a frame with respect to which the position of an object or the motion of an object can be described by a frame, and that frame is called as a frame of reference. Right? Okay. Now we know that if at all, if I want to explain it now here, right? For example, let me consider all the three axes. This is let me call it as x-axis, and let me call it as this is y-axis, and let me take this as z-axis. I cannot draw perpendicular to the board. Instead of, right, I am taking like this, right? This is z-axis. Do you understand? Z-axis is not here, it is perpendicular to the board. Instead we cannot draw here, so I have done the angle between z-axis and x-axis is 90 degree, right? So this axis is perpendicular to the board. Now let me consider duster is here. Right, I need to explain its position, right? I cannot draw duster here. Let me take the position as what we say here, P. Now, the position of an object I'll be explaining by considering x-axis, y-axis and z-axis, right? So do you understand? The object P is not on the board, right? It is outside the board. I cannot draw here. Instead, I will be taking like this, right? First, we need to know how much is its distance from x-axis, right? For example, if I am taking this is x now here, it will be x, y, z, because there are three axes. What is the distance of P from x-axis? That is this distance. What is the distance of P along y-axis? And this is the distance. What is the distance P along z-axis? And this is the distance, right? So this point is here. If I am considering here, what is this point P along x-axis? And this is x. Do you understand? This axis is perpendicular like this. So this is the distance itself, right? So this is x, this is y, and this is z. So we will be representing it as x, y, z. So this is the location of an object with respect to the reference point, and here origin is the reference point, right? So we know that the position can be expressed like this, x, y, z, but if the position is changed, right, then the body is said to be in motion. That time we require another one, that is time here, right? So the coordinates. So what are the coordinates? X, y, z with time, right? So coordinates with time constitutes frame of reference. Whenever we describe the frame of reference, we take coordinates as well as time, right? If you write the coordinates as well as time, it describes the motion of an object, right? The position or motion of an object can be described by considering coordinates as well as time. So coordinates with the time can be called it as frame of reference. So in order to explain frame of reference, I will be using coordinates as well as time, and both together constitutes frame of reference. Right? Okay. So a body, let me tell you about when the body is said to be in motion. See, a body is said to be in motion. See, a body is said to be in motion if any of the coordinates change what we say here with what we say here time. Okay, see here, if any of the coordinates change with the time, then the body is said to be in motion, right? If the body moves from this point P2, if this is a point what we say here P dash, if it is again changes took place along x-axis, it will be x dash, y, z. Means if a body moves from point P to point P dash, then we say the body is said to be in motion. So how to identify the body is said to be in motion? Any one of the coordinates, right? Any of the coordinates will change with the time. If it is moving along x-axis, x-axis will change. If it is moving in the space x, y, z, may also be changed now here, right? So if any one of the coordinates change with the time, right? So all the coordinates might change, xy might change if it is moving in a plane here, xyz may also change if it is moving in a space. So any one of the coordinates, if it changes with the time, then the body is said to be in motion, right? So do remember, we also require time. So when we speak about the frame of reference, it includes x, y, z as well as time here, right? So these all coordinates along with the time constitutes frame of reference. Now this frame of reference are of two types. We will be considering now here types of frame of reference. Okay, let me write now here frame of reference. Frame of a reference can be classified, let me take like this, can be classified into two types. Okay, frame of reference can be classified into two types, right? Based on how it, what we say here, moves, right? So based on how it moves, we can classify the frame of reference into two types. Okay, frame of references can be classified into two types based on how it moves, right? So there are two types of frame of reference. The first one is inertial frame of reference. The first one is inertial frame of reference, and the second one is non-inertial frame of reference. So frame of reference are of two types. One is inertial and another one is non-inertial. It depends upon how it moves, right? Is the frame of reference rest or it is moving? If it is moving, how it moves, right? It will decide whether the frame is inertial or whether the frame is non-inertial frame of reference, right? For example, if I am taking a bus is a frame of reference, a ground is a frame of reference. If you are moving in a lift becomes a frame of reference, right? We can bifurcate frame of references into two types, right? One is inertial and another one is non-inertial frame of reference based upon how it moves now here, right? Okay, now let us begin with the first one, that is inertial frame of reference. Inertial frame of reference or simply inertial frames. What are inertial frames? A frame of reference which is at rest or moves with constant velocity. Okay, do you remember? A frame of reference which is at rest or moves with constant velocity, right? In which Newton's first law holds good is called inertial frame of reference or inertial frame. So what is inertial frame? Inertial frame is a frame of reference which is at rest or moves with constant velocity. Okay, if the frame is at rest or if it is moving with a constant velocity, then that frame is called as inertial frame of reference. For example, if the bus is at rest, then bus is inertial frame. If bus is moving with constant speed, then it is also called as inertial frame, right? So if the frame is at rest or moves with constant velocity and in which Newton's first law of motion holds good. What is Newton's first law of motion? A body at rest will remain at rest, or the body in constant motion will remain in constant motion until and unless an external force is acted upon it. That is Newton's first law, right? Okay, that Newton's first law holds good in that frame, right? If Newton's first law holds good in a frame, then that frame is called as inertial frame. The name inertial means Newton's first law is also called as law of inertia. That is the reason why the name inertial frame we call it as, right? Inertial frames means it is a frame in which law of inertia holds good, or it is a frame in which Newton's first law holds good. right? We can say it like this. What are inertial frame of reference? It is a frame in which law of inertia holds good. It is a frame in which Newton's first law holds good, right? We can write simply like that, but we can write in this way also. It is a frame of reference which is at rest, or it is moving in a constant velocity, right? A frame of reference which is at rest or moves with constant velocity, in which Newton's first law holds good or law of inertia holds good. That kind of frame is called as inertial frame. And we need to know that inertial frame of reference or inertial frames, right? Inertial frame of reference is an unaccelerated frame of reference. Do remember, it is an unaccelerated, there is no acceleration, right? So if it is moving with a constant velocity, there is no acceleration. Means if it is moving 50 kilometers per hour, it is moving with 50 kilometers per hour. We are not putting any acceleration on it, right? It is not accelerated motion, or it is unaccelerated frame of reference. Do you remember? Inertial frame of reference is an unaccelerated frame of reference. Here acceleration is 0, right? If it is moving with a uniform velocity, understood that the acceleration is 0. So that is why we can say that inertial frame of reference is an unaccelerated frame of reference, right? Okay, it is an unaccelerated frame of reference, right? Let me take like this. Here in this, no fictitious forces arises in inertial frame of reference. Inertial frame of reference. Okay, I am speaking about inertial frame of reference. So these points you should know. No fictitious forces arises in inertial frame of reference. What are fictitious forces? Fictitious forces are the pseudo forces, right? Means actually the force do not exist now here, right? We will be understanding about fictitious force when I discuss about non-inertial frame of reference in which fictitious force arises. Just to note that in inertial frame of reference there is no any pseudo force, there is no any fictitious force. What is fictitious force? We will be learning in detail in the further concept now here, right? So one thing what you need to understand here is there is no fictitious forces arises in case of inertial frame of reference, right? Okay. In inertial frame of reference or in inertial frame, a body continues to be in the state of rest or in the state of uniform motion. See, in inertial frame, a body continues to be in the state of rest or in the state of uniform motion along the straight line until an external force is acted upon it. It is nothing but Newton's first law, right? In inertial frame, a body continues to be in the state of rest or in the state of uniform motion along the straight line until an external force is acted upon it. If I am taking this room as a inertial frame of reference, this is at rest now here, right? The body will be in the state of rest until and unless an external force is acted upon it. If a body is moving in uniform motion, it remains to move in uniform motion until an external force is acted upon it, right? So in short, I can say that in inertial frame of reference, Newton's first law holds good, right? Okay, let me give an example. Train at rest or moving in constant velocity, moving with constant speed. Let me call, since it is moving in a straight line, let me replace it by velocity. Train at rest or moving with constant velocity is an example of inertial frame. Right? If the train is at rest or moving with a constant speed, then the train becomes inertial frame of reference. Simple. What is inertial frame of reference? It is a frame of reference which is at rest or moving with constant speed, that is called as inertial frame of reference, and in that frame Newton's first law holds good. It is an unaccelerated frame of reference and there are no fictitious force acts in inertial frame of reference. So this is all about inertial frame of reference. Now let us move on to the non-inertial frame of reference. What are non-inertial frames? It is a frame of reference, which moves with variable velocity, depending upon how the frame moves. We can classify it into inertial and non-inertial. So non-inertial frame of reference are the frame of reference which moves with a variable velocity. A frame of reference which moves with a variable velocity in which Newton's first law does not hold good. Right, in which Newton's first law does not hold good is called non-inertial frames. Non-inertial frame of reference is called non-inertial frame of reference. What is non-inertial frame of reference? It is a frame of reference which moves with variable velocity. Means velocity goes on changing here. It might increase or it might decrease here, right? So a frame of reference which moves with variable velocity in which Newton's first law of motion does not hold good is called non-inertial frame of reference. For example, if you are moving in a bus here, suddenly if he increases the speed here, right? If he is at rest, if he suddenly increases that speed, and that if there is change in the speed, then that frame is called as non-inertial frame of reference. Means a bus which is moving with a different speed here, suddenly if he increases the speed or if he suddenly puts a brake and decreases the speed, at that time that frame is called as non-inertial frame. It is a frame of reference which moves with variable velocity, means increasing velocity or decreasing velocity, or if it is moving in a circle, that is also non-inertial frame. Okay, I'll be discussing about that in later classes now here, right? A frame of reference which moves with variable velocity in which Newton's first law does not hold good, right? So you need to understand that Newton's first law means if a body at rest remains at rest, if a body is in motion remains in a uniform motion until and unless a force acts upon it. Newton's first law. But it does not hold good if a driver suddenly puts a brake when you are traveling in a bus here. For example, if you are traveling in a bus and if the bus is moving now, suddenly he puts a brake, means what happens to the speed? Speed decreases. If speed decreases, then what now here? It is a variable velocity, then that bus becomes non-inertial frame of reference, right? If he puts suddenly brake now here, what happens? You move forward now here, right? Why do you move forward? Is somebody pushed you? No, right? There is no force acting on you, and even though there is no force acting on you, you move frontwards now here, right? So even though the force is acting on you, there is a motion in a body which is against Newton's first law, right? Newton's first law says if a body at rest, it should remain at rest, but when the bus driver puts brake, you move forward, right? Even though nobody is pushing, right? So even though there is no force acting on you, there is a movement of the object which is against Newton's first law. That is why we say that here Newton's first law do not hold good now here, right? So if Newton's first law does not hold good, then that frame of reference is called as non-inertial frame of reference, right? So do understand, non-inertial frame of reference, non-inertial frame of reference or non-inertial frame. Non-inertial frame of reference is an accelerated frame of reference, frame of what we say here, reference. Means it is an accelerated frame of reference. Non-inertial frame of reference, it can also be called as accelerated frame of reference. Means you are accelerating, you are either increasing or decreasing the speed. If you are either increasing or decreasing the speed, then we call it as accelerated frame of reference. I think you remember inertial frame of reference was called as unaccelerated frame of reference, right? So here it is called as accelerated frame of reference. So we can call non-inertial frame as what we say here, accelerated frame of reference. It is a frame of reference in which law of inertia does not hold good here. Law of inertia is nothing but Newton's first law, which will not hold good in this frame here, right? So this frame of reference is called as non-inertial frame of reference. Do remember, in this frame of reference, fictitious forces arises in non-inertial frame of reference. In non-inertial frame of reference. Do remember, in non-inertial frame of reference, fictitious forces arises, right? Fictitious force arises in non-inertial frame of reference. What is this fictitious force? It is a pseudo force which is not actually acting on a body, right? Okay, let me write that point now here. In non-inertial frame, right, a body experiences a force which actually do not act on body. See here, in a non-inertial frame, a body experiences a force which actually do not act on body, but appears to act on body. Okay, in non-inertial frame of reference, a body experiences a force which actually do not act on a body but appears to act on a body. So this kind of force is called as fictitious force. I told you, right? If a driver suddenly puts a brake, I move forward because there is no force acting, but what we say here, it appears to act now here, right? So instead, if I want to use Newton's law of motion in this case, I need to use fictitious force now here, right? So do remember, in this frame of reference, there actually one force arises. That force is called as fictitious force, or it is also called as pseudo force, which do not actually act on a body but appears to act on a body, right? That is why that force is called as pseudo force, or it is also called as fictitious force. Do remember, fictitious forces arises in a non-inertial frame of reference. In inertial frame of reference, there is no fictitious force like that now, right? So that was an unaccelerated frame of reference. This is an accelerated frame of reference. Here Newton's first law, or law of inertia, does not hold good. Okay, let me write: accelerated train, accelerated bus or accelerated train is an example of non-inertial frame of reference. Non-inertial frame of what we say here, reference. So accelerated train, right? A train at rest is an inertial frame of reference. Accelerated train is an non-inertial frame of reference. It happens the same way as it happens in the bus here, right? Do remember, it is an accelerated frame of reference. Means here there will be acceleration. In inertial frame of reference, there is no acceleration. Okay, let me tell you one note point here, that all accelerated frames and rotating frames, all accelerated frames and rotating frames are non-inertial. Do understand this, right? So this point you need to understand here. Whenever a body is rotating, right, so that is a non-accelerating frame of reference, right? So it is a non-inertial, it is a non-inertial frame of reference. Accelerated frame, of course, it is a non-inertial, even though the rotating frame is also non-inertial, because when the body rotates, see here, do you understand? If the body is rotating like this, if the body is rotating, even though it is moving with a constant speed, the velocity, do you remember? The velocity, if it is rotating like this, velocity is tangential. If it comes at this position, again velocity, means velocity changes. If velocity changes, then it is called as variable velocity, then it is a non-inertial frame of reference. Okay, you may ask now here, if it is moving with a constant speed, where is the acceleration? We know that acceleration is towards center, right? That is called as centripetal acceleration, right? So do remember, it is a centripetal acceleration. We call it as AC, right? So this motion has the acceleration. That is why the rotating frame, right, is also an example for non-acceleration frame. So it's simple. If a body at rest or moving with a constant speed, then it is initial frame of reference, right? If it is accelerated or rotated, then it is non-inertial frame of reference. You need to know what are the differences between inertial and non-inertial frame of references. Now let us understand about fictitious force, right? So fictitious force is a force which arises in non-inertial frame of reference. Okay. Fictitious force, or it is also called a pseudo force, which do not exist at all, right? But it is experienced by a body. It is a force acting on a body, right? A force. What is fictitious force? It is a force acting on a body due to acceleration of non-inertial frame. Due to acceleration of non-inertial frame is called fictitious force. Right? It is a force experienced by a body. It is a force acting on a body due to acceleration of non-inertial frame is called fictitious force. Right? It is a force acting on a body due to the acceleration of non-inertial frame. For example, I told you, if you are standing in a bus and if the driver suddenly puts a brake, means the acceleration has been reduced due to the acceleration of the bus, right? I move forward and the force, the pseudo force is acting on me, and that force is called as fictitious force, right? It is a force acting on a body, right? Why it is acting on a body? Due to acceleration of non-inertial frame, and that is called as fictitious force, right? For example, if I am considering here, right, if AC, if I am taking here, if A0 is acceleration, of non-inertial frame, right? Non-inertial frame. If A0 is acceleration of non-inertial frame, right? If you are standing in a bus, if the bus driver suddenly increase the speed, if you put leg on the accelerator and increase the speed suddenly, you go backwards. And the force which is acting on you when the speed of the bus increases, that force is called as fictitious force, right? What is the acceleration of the bus and how much you move backward, it depends upon the acceleration of the bus itself, right? That is why we say if A0 is acceleration of a non-inertial frame, then fictitious force, let me call it as fictitious force F0. Fictitious force will be minus A, what we say here, A0, right? It will be opposite to the acceleration of the bus. Do you remember? Fictitious force will be opposite to the direction of acceleration of non-inertial frame. If the bus is moving forward, you move backwards. That is why F fictitious force F0 is equal to, we get minus M into what we say here, A0. So what is minus what we say here? Mass into acceleration of what? Acceleration of non-inertial frame. Right? So this is the formula for fictitious force, and we can use this fictitious force to correct the equation of force. For example, as we know that in non-inertial frame, Newton's laws of force do not hold good. Newton's laws do not hold good. But if you want to make Newton's law to hold good, we need to add the correction, right? We need to add this force also, that is fictitious force, right? This fictitious force can be added to the equation of the force in order to use Newton's laws in non-inertial frames also. So this was all about inertial frames, non-inertial frames, and also the fictitious force here.